All right, we are moving on with our work on quadratic functions, and in this video we will look at a challenge and then a real-world connection problem relating to quadratic functions of best fit. I really encourage you to pause this video, try these on your own, and then check back in and see how you did. So for the challenge problem on the left, our task is to find a standard form function of best fit, yikes, by hand for the following data. So we know how to do it with Desmos. We want to try to do it by hand now. So let's take a look at it. One thing you might do, although I won't take the time now, but you might graph the points up and see if they look like a parabolic pattern. But the implication here is that we are trying to find a quadratic standard form function of best fit, so we won't take the time there. I'm trying to think through this here, give you a little bit of time to see what you can come up with. But are you seeing that we already have part of it done? Can you tell that our y-intercept is 14? So that's got to be C, right? So we already have part of it done. And then what we are going to actually do is take these points and plug those numbers in for x and y, and we are going to have a system of equations. So let's do it. Okay, so let's call this x1, y1, and x2, y2, or just our first set of points and our second set of points. So here we go. So number one, we're plugging in y equals, so 26 equals our unknown a times 2 squared, because that's x, plus our unknown b times 2 plus 14. And let's simplify that down a bit here. So subtract 14 from both sides, and we have a 12 equals 4a plus 2b. Let me double check that. That's all looking good. I'm actually going to divide both sides by 2 right away, just to simplify things down even more. So 6 equals 2a plus b. So there is one equation with a and b being the unknowns. Let's do our second one. And here we have a 70 equals ax squared, so our unknown a times x squared, plus our unknown b times x, plus our c of 14. Okay, so once again we can simplify that down, subtract 14 from both sides. We get a 56 equals 16 a plus 4b. Looks like we can divide both sides by 4. 56 divided by 4, is that 14? It is. So we have 14 equals 4a plus b. All right, so I think I have a good way to go here. I am going to bring this, let's bring both equations down below. I'll write the second one first, though, and you'll see why I'm doing that. And we have 6 equals 2a plus b. Cool. So we can do a big subtraction problem, and our b's will eliminate, right? Are we seeing that? 14 minus 6 is 8. 4a minus 2a is 2a. b's wipe out. Divide by 2, so a is 4. Okay, so now we know a, we know c, and we can plug this a equal 4 into any of the equations up above. So I can just take it and put it in here. So I have 14 is equal to 4 times a, which is 4 plus b. So it looks like b is negative 2. Okay, so we can write out our final equation. We have y equals, a was 4 x squared plus b, negative 2x, plus c of 14. That would have been a much harder problem if we didn't identify first off that c was a 14, okay? But there's our final answer to that guy. All right, next one, real world problem here. In my taco cart business, I made the following in profits over the first few weeks. It looks like I had some early good sales, then things tapered off, but as word about my spectacular tacos grew, my business picked up. So use a quadratic function to model the data and help me predict how much money I might make in the 10th week. So it looks like we have data up to the 7th week down here. And we want to try to predict how much money I might make in the 10th week. Okay, so we need to go to Desmos on this. I've already entered the data into a table over on Desmos, so let's do that. Let's head there. And so you can see my data entered on the left. I need to find an appropriate scale here. Okay, it looks like things are nicely quadratic, nicely parabolic here. So we can go to our standard form, best fit function. So y1, and we need to use the tilde, ax1 squared plus bx1 plus c. And let's then bring that back over to my note app, and we can annotate it, write on it, and explain what's going on here. Okay, so I'm going to paste it right down here. Let's see here. Let me actually go way down here so I can fill the screen with it. All right, so we got some good work here, some good results. So we have our coefficients right there, and we can write out standard form. By the way, looking at the graph, it looks like the function fits the data pretty well, pretty cleanly. You can see that I almost started to lose money, but then things picked back up nicely, so that's good news, and it looks like I have a good future in front of me for my taco cart. It looks like business is rapidly expanding, so that's good news. But anyway, let's write out our standard form function. Y equals 12.60 x squared. I'll go to 2 decimal points. Negative 53.96 x plus 65.71. And all I need to do is plug in a 10 for x, because we are looking for our y value for the 10th week. So, whoops. Y equals 12.6 times 100 minus 53.96 times 10 plus 65.71. So let's go to my calculator and crank through that. So 1260 minus 539.6 plus 65.71. Minus 539.6 plus 65.71, and I get an answer of 786.11. And then let's head back to Desmos and see if that looks reasonable. Okay, so I'm going to just zoom out a little bit, and Desmos can even actually tell us for us what it would be, and I'll go up to 10 weeks. And it looks like we are right at about 786. A little bit of rounding difference from what I got, but almost $800 in either sales or profits for that 10th week. So looks like we did it correctly. That's a good place to stop.